press the bell icon on the YouTube app and never miss another update.
Hey children, I hope we have clearly done with the first chapter, or we have completed with the first chapter, that is motion in a straight line. So, first chapter in the sense in kinematics, one part which I have mentioned. Prior to that we have already studied physical world, units and measurement, and in continuation to that we have studied with motion in a straight line. And the other part of kinematics, that is not just in a straight line, motion in a plane. Given in the beginning of the introduction of this classes itself, I have mentioned what do you mean by straight line and what do you mean by plane in which a body is moving, what properties we have to study, everything we have studied. So, in that course, so from today we are going to study with this chapter motion in a plane. Motion in a plane. We will go with that. So, before going for everything into this chapter, I hope you have come across units and measurements already. That means units and dimensions and vectors, and particularly about vector analysis. What are the different types of vector? What do you mean by vector first of all? What are the different types of vectors we are having, right? What do you mean by scalar? Difference among those scalars and vectors, different physical quantities, right? So, from basic definition of the vector, types of vector, and some of the properties also have studied about this, like vector addition, how you need to do with vector addition. If I want to add two vectors, right? So, there is some laws we have studied, parallelogram law of vector addition or triangular law of vector addition, like that we have studied about the addition of vectors, and even subtraction of vectors we have studied, and also you have come across multiplication of vectors. Unlike just two numbers, when you are going to add 2 plus 3 gives 5, you can't add vectors in that same way. So, you have to take into the consideration of the direction of the vectors, and we have to add those two. For that we have parallelogram law and triangular law we have studied, and based on that what do you mean by magnitude of the vector as well as direction, how to find out, all these things we have studied. We have already come across those things. So, why I am stretching this concept of vectors here means, in NCERT textbook, if you take out after completion of motion in a straight line, in motion in a plane, first it is given with vectors. Vector analysis has been given first, means types of vectors and all those what you have studied in vectors chapter, right, or vectors topic earlier, which it is telecasted already. So, in that vectors what are all it has been discussed, right, that is in the first you are having in this chapter. After learning with everything about the vectors, then only we will move on to actual motion in a plane chapter, or into the topic of motion in a plane. We will move on after learning only about what? After learning only clear with what? Vectors. Okay. So, now before going for this chapter once again, I just want once again a recall of vectors what you have studied, which are all essential for me to in order to discuss in this chapter. If I want to talk something about a displacement, velocity or acceleration, vector components or vector notations I need to mention. So, for that basic things I am going to first let me know, I am going to have it once again. So, like if I am having a vector, let me say this is x axis and this is y axis. You know how to resolve a vector into components. Straight away I will go with the resolution of vector, which we have already studied with. Like if I am having a vector a bar, let me say, whose magnitude is a. What is the magnitude of this vector? A. Magnitude of a bar is a, and it is making an angle theta with horizontal. You are going to resolve this vector into two components you have already studied, that is called resolution of a vector, means resolving a given vector into its rectangular components. How you need to resolve a vector into its components? This component we used to call it as horizontal component or x component. I will suppose to write it as some ax, and this is what is the component in this direction, vertical direction. I am going to take it as what? Ay. How to write this horizontal component? Ax equals to a cos theta. You have already studied this, that is why I am just recalling what you have studied. These are all essential or required for us while studying about. So next ay it will be equals to a sin theta. These two are two rectangular components of this vector. Meaning is, see, you can also call component or projection of this vector in this direction. What will be this? What will be its projection in x direction? What will be its projection along y direction? That it is even called as what? Component. What will be the component of a bar along x axis, you can say, or what is the projection of this vector a bar along x direction? Both are on the same. Keep it in mind. So now ax is a cos theta and ay is a sin theta. Blindly you just remember wherever theta falls with which vector is going to make, that particular component makes cos, the other one is sin. And in x direction, what is the component? What is the direction you are going to mention means I cap. And in y direction, what is the component you are going to unit vector you are going to mention is j cap. So this vector a bar, I can write this one as what now? Ax I cap plus ay into j cap. See, ax into I cap plus ay into j cap. What is ax here? A cos theta. What is ay? A sin theta. Got it? So I can rewrite this relation as a bar it will be equals to a cos theta into I cap plus a sin theta into j cap. This is how you are going to resolve a given vector into component. In component method, if I want to write the vector, right? So this is how we need to write. A cos theta is what? X component. A sin theta is what? Y component of the vector a bar in this given xy plane. So that's how we need to write for a vector representation, which you have already learned with. I am not going to have all this once again. So in vectors you have learned. So these are all required for us, that's why I am just recalling them. Okay. So this is one thing. And one more thing is like, if I am having two vectors like a bar and this is another vector, some b bar if I am having, what is the resultant of these two vectors? What is the meaning of resultant? Resultant is nothing but adding these two. What is the resultant? R bar, it will be equals to a bar plus b bar. You have studied this one. This is the resultant. And how to find the magnitude of the resultant of two vectors means mod a bar plus b bar. Magnitude of, when I am going to add these two vectors, right, what will be the magnitude of that resultant? That is root of, if I say theta is angle between a bar and b bar, then a square plus b square plus 2ab cos theta. So this is what which you have already learned with. And also this angle alpha value also we have learned. How to write for alpha? Alpha equals to tan inverse of, or tan alpha it will be equals to, directly I can write, tan alpha it will be equals to what? D sin theta divided by a plus b cos theta. See these derivations and all these formulas, it may be p or q they have teachers have taken, or it may be a or b or c or d, whatever it may be the vector. How to write for this magnitude and direction of the resultant? Magnitude of the resultant as well as direction of the resultant, how to write? You have to remember with these two once again as it comes to the concept of vectors. After this, see, we have not yet entered into this chapter. I am just having a brush up of vectors what you have studied, which is required for us. Okay, so it will be easier for you to move further into these topics over there. So now we'll start with actual topics related to this motion in a plane. In the first chapter, that is in the first part of this kinematics, that is motion in a straight line, I told you very beginning session. So when an ant, if I am going to take, right, if it is started to move, if it moves only in one direction itself, either it is moving only in x direction, or it moves only in y direction, or it moves only in z direction, then its motion is confined to straight line. That is motion in straight line we have studied. Means it just keeps on moving along one direction itself. Okay. So now when it comes to the same ant, if I say this is x and this is y, somewhere it is started at this point. It's not just moving only in x direction now, or it is not moving only in y direction. It's supposed to travel somewhere to this particular point. Let me say this is O to A. That's how the ant has been moved from where to where? O to A. If you observe here, Even whether it is moved in a straight line path itself, let it be however it is, whatever the path in which it has been traveled, let's say it has been moved in the straight line path. From where to where? O to A it has been moved. Okay. So now if you observe, is this ant traveled only in one direction here? Can you say that it is traveling only in one direction here? No, you can't confine this motion to the one dimensional here. Why? Because with respect to this plane, this is the frame of reference which I have taken, XY plane with respect to this frame, right? So ant has been moved, see, this much amount of x distance means what? In horizontal direction, see, this is the length, horizontal distance it has travelled. Only horizontal distance it has travelled? No, it travelled even vertical distance also. How much is the vertical distance it has travelled? Y. So now, if I want to study the motion of this particular ant, in where? XY plane, in plane it is moving now, not in straight line, it is in moving in plane. So how many coordinates do I require? Means 2 coordinates required in order to represent a point anywhere. If I want to study something about in plane, about plane, right, I do require 2 coordinates. Anyway, not only just the position of the particle, from here on, just like how you studied various parameters like position of the particle, displacement, velocity, acceleration and all other parameters in straight line what we have studied, once again we have to recall all this here. Okay. So now first of all, in order to represent a position of a particle in plane, how many coordinates we are in need of? We are in need of 2 coordinates. How many coordinates? 2 coordinates. If I say the same like a mosquito when it is flying somewhere on one corner of the room to in front of you, if it has come for example, then it has travelled x distance as well as it has travelled some y distance and even it has travelled some z distance. 3 coordinates are required in order to represent the motion of the mosquito somewhere from corner of the room to the center of the room. So that is 3-dimensional motion. So this is 2-dimensional motion. Plane confined to what? 2 dimension. Remember, this is 2-dimensional. 2D motion in 2D also we can say. Motion in a plane are 2-dimensional. Motion in straight line is what? 1-dimensional it is. In only one direction it is supposed to move. That is 1D. This is 2D. Motion in 3-dimension or motion in 3 dimension is nothing but in space. If I take, that is nothing but what? In 3 dimensions. 3D it is. Our syllabus is confined only up to what? This 2-dimensional plane. Motion of all the particles. How particularly under uniform acceleration. That to remember. Under uniform acceleration we are going to study. It's even once again comes under what? Kinematics only we are studying, right? Uniform acceleration. For all the bodies which are moving in uniform acceleration in plane, we are going to study in this particular chapter. So now we will start on with the basic definitions or how to represent all those physical quantities which we have already studied. Once again, I will repeat, the quantities which we have to study is, here we have to represent first position vector. What do you mean by a position vector? There we have studied position of a particle means at x equals to 2 meters, straight away we told. Position of the particle is at x equals to 2 meters we told. But in vector form, if I want to represent the same position, how I can represent? So that we have to study. What do you mean by this position vector? And then we have to study about displacement vector. Next thing we have to study displacement vector. How in plane we have this already we have studied with all the definitions, everything. But how to represent the same displacement in plane, how to find out? If it is only in straight line, with examples also we have studied. With examples I have given a body moved from A to B, B to C, again from C to B if it has come. Likewise, only in straight line we have studied. If it is in plane, then how you need to study for this displacement. And similarly, another parameter, what is that? Velocity, how to find out. And acceleration, velocity, acceleration and so on. Similarly, the average speed, average acceleration. After learning all these, once again we need to move on to what? Equations of motion. What are the kinematic equations we have studied? V equals to U plus AT. S equals to ut plus half at square, v square equals to u square plus 2as and Snth equals to u plus a into n minus 1 by 2. What are all equations we have studied there in straight line, right? Here we have to study in plane also the same kind of equations. How we supposed to write those kinematic equations? in case of plane, that we have to study, right? So after that we in the course of discussion I will tell you what are all we are going to study about. So basically first we need to study all these things when it is confined to the plane. So first let me start with the position vector. So what do you mean by position vector? Position vector. See, I am having a point x comma y in a plane. P x comma y is in plane. Position vector is a vector which is drawn from origin. See carefully. Position vector of this point P x comma y is a vector which is starting from origin and directed to that particular point for which you need to find the position vector. See, from origin you need to see, with respect to origin all the position vectors are going to be defined in this plane. Keep this point in mind. With respect to origin, from origin where the point is going to be present here, you just draw a vector represented like this. This is what a vector. This is the position vector of this particle. See, position vector of a given point or a given position in a plane is a vector which is drawn from origin to the corresponding point. A vector which is drawn from where? Origin directed towards what? That particular point for whose position is going to be given. That is what? Position vector. So generally it is represented as r bar, let me say. What is that position vector represented as? R bar. Instead of saying there is a point P x comma y in this plane, xy plane, I can say that position vector of this point, see carefully, position vector of this point x comma y is r bar. How to write r bar? I told you, that's why how to resolve a given vector into components. This is x value and this is y value in the sense, then how to write the value of r bar here now? R bar equals to xi cap plus yj cap. This is position vector of, see, this is position vector of a point P x comma y in xy plane. That's how we need to write for it. See, position vector of a point P x comma y in xy plane is what? Xi cap plus yj cap. So that's how we need to represent. I hope you got this point. Once again I will just recall. See, position vector of a point in a plane is a vector which is drawn from the origin, which is directed to the point with respect to which you need to find out the position vector. So you need to start from origin and you have to direct it from where to where? Origin to that point. And that arrow is directed towards that particular point. So that's how we need to define for position vector of the particle. I hope you got this. This is how you need to write the position vector. So some examples also, let me say. From here on, whenever it is required for you to write the position vector, not only in your first PU, in your second PU, or if you go for your graduation anywhere like bachelor graduation like engineering or any other courses, if they are given a point and its position vector means simple way you have to write. Likewise you have to learn. I will teach you one more, I will give some examples even. You yourself can analyze even like how to write for it. You can take some more examples by your own and you can also solve for them. So as of now I will give few more examples here. See, this is for xy plane. In first quadrant it is. If I say, straight away I will give some numbers, you have to say now. Okay. So x and y, like this I have taken. I am having a point P1 here. This is another point P2. Let me say here it is some P3, P4, and this point is some P5, and this is P6, P7. These many number of points I have taken. This is positive x, negative x, positive y, negative y. First quadrant, you are all aware. This is second quadrant, third quadrant and fourth quadrant. I am going to take some arbitrary numbers here like let us say this point P2 is some 1 comma 3, let me say. This is some, or it is some 3 comma 3 I am going to say. This is some 2 comma 5. This point 6 on y axis it is at a location of some 2 meters, this is 2 comma 5 we have taken, and this is see on negative x-axis minus value, positive y-axis plus y value. 0.3 will be like I will take it is some minus 2 comma 1 or something I have taken, right, and here both are negative values you are going to write. X is negative as well as y is negative, so that's why P4 I will take it as some minus 3 comma minus 1, and this is something I will take the value as some minus 5, let me say, right, and this is P7 is some minus 6 comma minus 2 or something I am going to consider. Let it be. So I have given so many points over there here now. We need to write down all the position vectors of all these. Okay. So I told you position vector means starting from where? Origin. You have to draw. First point P1, let me draw for P1. This is what the vector which we have drawn for this P1. How to write this is, I am going to say it as some R1 bar position vector. Just tell me now how to write for R1 bar position vector of R1. A position vector of that point P1 is nothing but what? R1 bar will be equals to, how to write? What are the x and y coordinates here now? 2 comma 5. In which plane? XY plane. That's why straight away I will write here now. This is 2i cap plus 5j cap. In unit if you want to write it is meter. Centimeter or meter distance now from here to here, that's what. That's why I need to represent the position of that particle, right. So R2, this is what P2, right. R2 means what? From here to here only, na? This is some R2 bar I will say, right. R2 bar, now you tell me how much it is. R2 will be equals to 3i cap plus 3j cap, 3i cap plus 3j cap. So likewise, if I take this point, this is 2 meter mark, P6. P6 is on which axis? Only in y direction. What will be its position vector? I will take it as some R6. R6 will be equals to, is there any x component on y direction? X value will be 0. That's why it is 0i cap plus, on y axis it is, right, how much distance? 2. That's why it is 2j cap. Or I can say like R6 equals to position vector of point P6 is how much? 2j cap meter. Like this you have to write. P3 you have to write down, it is work for you. You do it and you just represent how much it is. I hope you can do that. And let me write for this one P4 now. P4 is what? Once again see, like this you have to represent from here to here. P4 means R4 bar it is. R4 bar, you tell me how much it is now? On x axis minus 3, that's why it is minus 3i cap. On y axis how much? Minus 1, that's why it is minus 1 into j cap. Or I can write R4, it will be equals to, how much is the value of R4 now? Minus 3i cap minus j cap meter. Like this you have to write for R4. And see P5, that is R5 is your work. You have to do it. From where? Origin to this point, means see, or else I will write there itself. R5 it will be equals to, how much is the distance we have taken here? Minus 5. That's why it is minus 5 in which direction? J cap. That's why minus 5 j cap meter. Like this. You take for this value from here to here na P7. So this is R7 I can take position vector. So how to write for R7 now? Minus, this is positive value you will get here, right? Positive x axis no. It is positive x axis, that's why it is 6i cap minus 2j cap. This is how we need to represent the position vectors, how you need to write for any given point in a plane. Whenever they are given in a plane, a point if they are given, how to write the position vector of that particular particle means this is the way how you have to write and you have to represent it. So I hope you got everyone what do you mean by position vector and how to write the expression for our this position vector equation. If you want to write on vector equation, if you want to write, you know how to write for it, we have learnt. Next, displacement vector we will see. What do you mean by displacement? And this is part 1 of the class, first class no? I will say it is part 1. Okay. What do you mean by displacement? Next one is what? Displacement. What is the definition of displacement we have studied in first chapter, previous chapters in straight line? It is shortest distance between 2 points we have studied, right? From one point to other point when the body has travelled, shortest distance is displacement we have studied. Or if you want to study the how to find out the displacement, means we have studied x2 minus x1. Final position minus initial position, irrespective of the path it has travelled. From one point to other point if it has travelled, then what is x2 minus x1 we have studied. Y only x means travelling only in x direction. If it travels only in y direction, then I would have written y2 minus y1. That is displacement what we have studied in first in one dimensional motion we have studied. Now when it comes to two dimensions, vector representation is must unnecessary, and we will see how to write for it. I will say a body is moving in xy plane likewise, okay. It has travelled in some path, let me say like this, okay, or for our convenience, so like this it has been travelled. I am going to take an arbitrary point somewhere here, it is A, and this is another point B I have taken. It has been moved from A to B. It has travelled in some path. It is not travelled only in straight path here. So what is the displacement of this body when it has been moved from A to B, they will ask. Now how to find out the displacement when a body has been moved from A to B? Let me say they have given A is nothing but some x1 comma y1 and B is a point that is x2 comma y2 they have given. Let me say A is what? x1 y1 and B is what? x2 y2, these 2 points they have given there. And our intention is to find out the value of what? Displacement. No doubt shortest distance between initial and the final position, I can say it is nothing but what? Displacement. When it comes to vectors, right, in plane whenever it is moving, see, you have to write position vector of this point A here now. What is the position vector here? This is what the position vector. What is this? R1. Position vector is what? R1. And this position vector is from with respect to this point origin, right? I will say this is the point here, or else. What is this one now? R2 bar. Position vector R2 bar, and this is what? R1 bar. R1 and R2 are the position vectors of A and B when the body has travelled from A to where? A to B. How to write the position vector? Displacement of that particle from A to B means final position vector minus initial position vector. R2 bar minus R1 bar itself is nothing but what? Displacement. What is that? Displacement is R2 bar minus R1 bar. Now, where to where it is travelled. Now, how I need to represent? Where is R? Once again, it should be a vector. Just like R1, it is from here to here, right? So, R2 will be from where to where? Here to here. Then, what is the direction of R2 minus R1? R2 minus R1 will be from where to where? How to write for it? In vectors, you have already studied subtraction of two vectors, how to write. Subtraction is also nothing but what? Addition only. See, R2 plus of minus R1, you have to find it out. This is what the displacement. Okay, R2 plus of minus R1. This S bar value, displacement value, or you can say, if for your convenient, it has travelled from A to B, right? This is what the displacement, shortest distance you are going to have. This is what S bar it is. Okay, see, R1 plus S will be equals to R2 according to the triangular law which you have studied. See, these are two vectors taken in the same direction. Then the third vector taken in the reverse direction give the resultant. Means R1 plus S. If you take this to the other side, it will become R1 plus S will be equals to what? R2. R1 plus S will be equals to what? R2. Or else you will get S, it will be equals to R2 minus R1. S will be equals to what? R2 minus. This is what the displacement vector, how to write. From where? A to where? B. That's how I need to try. When the particle has travelled from A to B, position vector of this, it is, displacement vector is going to be written as R2 minus R1. This is the way how we have to represent it. Okay. So, if two vectors, if they are given, or 2 points in the plane, if you know, and if their position vectors, if you are able to write, then we can find out the displacement vector easily. How we can find out? just final position vector minus initial position vector of that particle. Okay. So this is the way how we have to write for the position vectors. So now here can you tell me how to write what is R1 bar here, can you tell me? Here R1 will be equals to, what is the position vector of R1? We know the point x1 comma y1, right? So that's why it is x1 I cap plus y1 j cap. R2 is what? R2 is x2 I cap plus this is y2 into j cap. So then displacement vector means what? R bar R2 minus R1, this is R2 x2i plus y2j, or else let me write x2i plus y2 j cap minus this is x1i cap plus y1 into j cap. Okay, na? Or else I can write this one as I cap, I will take common c here now, x2 minus x1 will get, this is I cap into x2 minus x1 plus, I will take j cap common now, j cap into y2 minus y1. So this is how we need to write down the displacement of a particle which is moving on this path, whatever may be the path it has travelled, right? If you know how to write the position vectors of that particle at different points, right? So how to find out the displacement between those 2 points means just the difference of these 2 position, final position vector minus initial position vector, you have to do it. So this is the value of displacement, displacement of particle when it has been moved from where to where? A to B. That's how I need to write for it. I hope we got this point. Some examples I will give, you have to do it now. Here itself I am throwing the examples, keep this point in mind. Just where we have done with the concept, there itself an example if it is given, it will be easier for you to analyze further while solving the problems, or when you are going to analyze with the concept, right, it will be very easier for you. I hope you got this point. If it is not, once again just go through this point again. So this is about what? Displacement vector. It do has some magnitude as well as direction. Again, I need not to mention what you mean by magnitude and how to find the direction of that. Why? Because in vectors which you have already studied. Now I will give an example, just an example I am going to give it. Like the particle started from A 2 comma 3, A 2 comma 3, 2 and ended up at B 5 comma 6. B 5 comma 6. Then what is the displacement of this particle moving from A to B, they will ask. What is the value of displacement, they will ask them. How to find out the displacement means position corresponding to this A, position vector corresponding to A, I am going to call it as some R1. Position vector corresponding to B, I am going to call it as some R2. We know how to write the displacement means R2 bar minus R1 bar. R2 bar is here, how much here it is? 5i cap plus 6j cap. I hope you got this. Minus, what is R1 means? 2i cap plus 3j cap. This is what the displacement is. Now how to find this, tell me now. You know this, what is this? Subtraction of 2 vectors, how to find? 5i minus 2i, 3i. This is 3i cap. 6j minus 3j, how much it is? Plus 5 minus 2, 3, 6 minus 3, 3. 3i cap plus 3j cap. So many meters. This is what the displacement is. What is the magnitude of displacement means? Magnitude of displacement, how to find out means? Magnitude of displacement. How to find out? Mod S, it will be equals to, you know how to find the magnitude of this directly, root of 3 square plus 3 square plus 2 into 3 into 3 into angle between these two is how much? I cap and j cap angle is how much? 90. That's why cos 90 it will be 0. I hope you are all thorough with that already. So that's why directly I have written. Two vectors are perpendicular, then the resultant will be root of a square plus b square. Likewise we are going to mention. So this is something you can mention, 9 plus 9 how much it is? Root 18 meters or whatever it is we are going to write like this. How to write the direction? Direction how to write down? See? 3i plus 3j means this is what the vector, right? This is what displacement vector we are having. How to write down means, if I say this is theta, tan theta it will be equals to, see, in this y coordinate by x coordinate I can write. Y coordinate is how much here now? 3. This is tan theta equals to 3 divided by x coordinate is also how much it is? 3. So that's why it will be equals to what? 1. If I write theta will be equals to how much now? 45 degree. Why? Because tan 45 is 1. So that's why theta equals to how much? 45 degree. Like this, this is the direction. You can say it is make an angle 45 degrees with positive x axis. You can say like that. So that's how we need to write down for displacement. Direction is displacement is make an angle 45 degrees with positive x or 45 with even a positive y axis also, positive x or positive y. Likewise you can mention. Magnitude is root 18 meters. Okay, so that's how I need to supposed to write for this displacement. How to write down means this is the way how we have to write for it. I hope you got this, how to write the displacement. Next, velocity. So all for plane what you have to learn. Within straight line you have learned only when it is moving in one direction, whereas in plane in 2 dimensions when it is moving, right, you are supposed to write. So now same velocity, how to write? Definitions I am not giving here. Definitions retains the same what you have studied in straight line chapter. The same definitions will retain here. Velocity is nothing but rate of change of displacement. Displacement, okay. Straight line shortest distance between initial and final position is displacement. The definitions retains the same, but the way how you have to represent those, whether it is displacement or velocity in plane, that's what we are learning here. So now I will say like a particle has started to move in x direction. Okay, it has started to move in which direction? X direction. Towards east, I will say, let me take the directions over there. Towards east, it travelled for 20 meters and then immediately it turns towards north and travels for 20 meters. Right, what will be and the time it has taken to travel the distance is for first time, or let me write that a body travels towards east for 10 meters, or some our convenient I will take it as some 6 meters in travels for 6 meters towards east for 6 meters in 5 seconds, and then towards north, and then towards what? Toward north for 8 meters in some 3 seconds, let me say 8 meters in 3 seconds. What is the velocity of this body? They will ask for it. How to find out the velocity? Average velocity, if you want to find out from one point. Velocity is nothing but what? Rate of change of displacement. Overall, from starting from origin, right, it has travelled towards east and then towards what? North. If I say this is north, south and west, right, it has travelled towards north. North for how much distance they are given? 8 meters, and east for how much distance? This is, sorry, east is 6 meters and this north is how much it is? 8 meters it travelled. Okay, so then what is the average velocity of this or direction, anything they are going to ask? If this kind of problems if they are going to ask, right, how to solve for it? How to solve means, first this is first displacement or position change, how to write for it? Or you know this point how much it is? This is 6 and 8 means this is 6 comma 8. What is the position of this particle now? This is the final position, this is initial position 0, and this is what? 6 comma 8. Finally this itself is a displacement, right? That is one method you can write. Or if you take east along x direction and north along y direction, if I take, first initial total displacement we have to find out. Total displacement is S1 plus S2. Total displacement it will be equals to how much now? S1 plus S2. Why? Because this is first displacement and this is second. If any other one is there, third you can take and so on. Yes, it will be equals to S1 plus S2. What is the value of S1 here? 6 I cap plus, what is the value of S2 here? 8 j cap. 6 I cap plus 8 j cap. So this is the displacement. Okay, time taken, total time of journey is how much? For this journey, time taken, they are given it is what? 5 seconds. And for this journey, they are telling that it is taken some 3 seconds of time. So total time is how much now? 5 plus 3, that is 8 seconds. So how to write on the velocity vector now? V bar, it will be equals to displacement divided by time taken. What is the value of displacement we got? 6i cap plus 8j cap. This is 6i cap plus 8j cap divided by time taken is how much? 8 meter per second. This is how we need to write for velocity. How to write magnitude of velocity means, once again, modulus of this you have to take. Mod v equals to 1 by 8, you can take common, root of 6 square plus 8 square. What is the magnitude of velocity here means? Magnitude of velocity, that is nothing but speed, will be equals to root of, see, 1 by 8 is common, I can take out when you are finding out. This is 1 by 8 into root of 6 square plus 8 square. This is 6 square plus 8 square. What is the value of 6 square plus 8 square? 100. Root 100 is 10. That is 10 by 8 meter per second is what? Magnitude of the velocity of the particle traveling from O to this point 6, 8. Or for the total distance, velocity of the particle will be equals to what? 10 by 8. Direction if you want to find, same. Theta equals to tan inverse of y coordinate divided by x coordinate, you can find it out. If you solve for it, you will get the value like 8 by 6, you will get there. Tan theta, it will be equals to tan inverse of 8 divided by 6. 8 divided by 6 means, and then this angle will become what? Like this is what? This is the displacement, right? This is the theta, this is east and the north if it is, right? This angle we used to call it as what? North of east. You have to call this angle as how much now? North of east. I will discuss about this angle once again, how to represent what is the meaning of east of north or north of east, when you have to call it as northeast, when you are supposed to call it as that is southeast or something like that, north of east. In the coming sessions once again I will come back to you. As of now it is not required, I will discuss that point also, I am going to mention. See, that is why you need to find out what? Velocity vector, how to find out. Or if I want to mention velocity vector, V bar, it will be equals to delta r bar divided by delta t. That is why I need to write for change in position of the particle is nothing but what? Displacement, and time taken for the change in position of the particle, that is nothing but what? That ratio itself is velocity of that particle. This is how we need to represent the vectorial representation for what? This vector representation for what? Velocity. That is how we need to write for it. I hope you got this point. Next we will move on to acceleration in the same way. Next, acceleration. You know, acceleration is rate of change of velocity, right? Acceleration A equals to what? Change in velocity divided by time taken for the change. Delta V by delta T, supposed to call it as what? Acceleration. So when you are writing for acceleration, change in velocity by change in time taken, what is the meaning of that? What is the meaning? Just like the displacement, how we have studied, we have to write for velocity here now. How to write? How to write the direction of acceleration, right? In the coming sessions, when we are studying with, right, when we are going to learn with all this, when we are into that actual problems, when you are going to solve, you should be very comfortable with finding out the angle. That is why I told you in the beginning itself, vectors representation and vector addition and vector, how to find the direction of a given vector, all these you should be very familiar with. So when you are learning with this chapter or when you are going through this, if you are 100% thorough with the vectors, well and good, or else my request is once again go back to the vectors topics wherever it has been given, those videos you can go. Just go through with those videos of the vectors, how to find out all those parameters like direction, how to find, right, how to find out the magnitude, okay. So how we need to represent the given vector, how to add, subtract, right, addition, subtraction, up to that you be thorough for this chapter. Multiplication we will see later in work energy, power and so on, so chapters it is required. As of now it is not required. You just have an idea like how we need to write for it. So now how we need to find out the value of acceleration. What do you mean by this change in velocity of the particle, right? I will say the same example which I have taken earlier, I am going to take once again. A body is moving with a velocity v1, this is what v1 bar, right, for a time of t seconds towards east, it moved for a time of t seconds with what velocity? v1, and after that, after t seconds it turns towards north. Let us say this direction is north, this is west and south. It turned its direction towards what? North, and travelled with a velocity of v2 for a time of, I will say it is some t2 seconds. What is the acceleration of the particle for this journey, they will ask there. What is the acceleration of the particle for this journey, they are going to ask. How to find the acceleration means, a bar it will be equals to, I told you, change in velocity v2 bar minus v1 bar, final velocity minus initial velocity divided by time taken for the change is how much? t2 minus t1. Okay, time taken for the change is, for example, from here to here total is t2 and up to here is t1 means you can, or it is total time of change. From here to here is t1, here to here is t2 means total time taken for that change is how much? t1 plus t2 you have to take here, or else if they are given directly delta t is the time for which this change in velocity has been took place, then directly I can write for what? Delta t. A it will be equals to v2 minus v1 divided by delta t. That is how I need to write for acceleration. I will give some examples there and I will ask you to do with directions also, how to find out magnitude, directions and everything. Just have an idea for this acceleration, how to find out means change in velocity divided by time taken. Here only thing you have to remember is, only thing you need to learn, you need to have into your mind is how we can add two vectors, how we can subtract two vectors, and how we can find the direction of that addition or subtraction. That means the resultant vector's direction as well as magnitude, how to find out. So these two you need to be learnt with when it comes to what vectors are going to be concerned. So with that only it will be easier for you to do all those things. So now examples we will look on to this before going for the body moving with uniform acceleration. I just want to confine in today's class itself with how to find out some examples I will give there. So like velocity how to find out, okay, acceleration how to find, or displacement how to find, so and so points if I want to write for it. I will give some example problems we will take here itself in plain example. First one, we will start with the displacement. A particle moves along x direction, moves along x direction for 10 meters in 2 seconds, along y direction for 5 meters in 3 seconds, along 5 meters in 3 seconds. Then find first one, displacement. Second one is velocity. This is average velocity, I am going to say average velocity of the particle, and what will be its acceleration also. What will be its acceleration? acceleration. These three parameters I just want you to find it out. With this example, we will see how we need to find out all this. Okay. So, I hope you have noted down displacement, velocity and acceleration we have to find. Problem is a particle moves along x direction for 10 meters in 2 seconds and along y direction for 5 meters in 3 seconds. This is the problem what they are given. So, to find out the displacement, first what we need to do, we will see. Displacement means both magnitude as well as direction I want here now. How to find out, we will study. See. This is x, y, right? This is the x and y axis. So now, particle travel, first one is displacement, right? How to find out displacement means? Two directions it has been changed. If it has traveled only in one direction, directly I would have written only 10 meter in x direction. See, x direction 10 meters means 10 I cap, that's what. Whether it has stopped there itself, no, it has taken again, it has been moved in y direction for how much? 5 meter means what? Plus 5 j cap. This is a displacement. This is a displacement. Okay. So, no need to bother about the time when you are writing for what? When you are writing for displacement, no need to bother about the time of the particle. So, what is magnitude of displacement if they ask? What is this? This is what displacement of the particle is. Displacement. This is what the displacement is. Magnitude, how to find out, tell me. Magnitude, if I want to find, magnitude of displacement if I want to find, mod s equals to root of, I told you already, you should be very familiar with solving for magnitude, direction and everything. 10 square plus 5 square. This is what? 10 square plus 5 square. Okay. So, how to represent here means this is what? Means in this direction 10, in this direction how much it is? 5. That's the meaning of it. 10 I cap plus 5. This is angle made theta. Magnitude how much you got? Tell me. 100 plus 25 is what? Root of 125 meters. Let it be whatever it may be. Root of 125 meters. Theta how to find out now? Direction of displacement. Direction theta equals to, how to find out means tan inverse of y coordinate by x coordinate 5 by 10. This is 5 divided by 10, or it is tan inverse of 1 by 2. See, this was the value of theta. Y coordinate is how much here? 5 and x coordinate is how much here? 10. That's what theta equals to tan inverse of y by x, tan inverse of 1 by 2. Now, how to call this angle as? Or if you take, see, it is measured from x axis to this angle, right? This is always taken as positive. From x axis, it is in all the anti-clockwise direction, if the angles are going to be made with respect to x axis, all the angles which are measured with in anti-clockwise directions are going to be taken as positive. For example, I am having this value, if I take this angle as some theta, then this angle is going to be measured from positive x axis in which direction? Clockwise direction. Then this angle you have to take it as negative. So, that is some sign convention or rules when you are writing for whether the angle is positive or negative. In mathematics you have to remember with. Once again I will recall, with positive x axis, if you measure the angles in anti-clockwise direction, those angles are to be taken as positive. With respect to positive x axis, if you measure the angles in clockwise direction, any angle which is measured in clockwise direction, with respect to what? Generally we are going to take the reference as positive x axis. Or even here also, if I take with respect to negative x axis, if I say this angle is 30 degrees, let me say, when you have written theta equals to 30, whether you need to take it as this angle as positive or negative, means with respect to negative x axis, see, this is negative x axis, no? It is moving in which direction? Clockwise or anti-clockwise? Anti-clockwise only, no? So, anti-clockwise direction, that's why theta equals to plus 30 degrees we will write, that's so. Or if I say this angle is some 20 degrees, if I am going to mention, let me say, how to say this angle now? Angle made by this vector with negative x axis, can you say it as theta equals to plus 20 here now? No, why? Because with respect to negative x axis, this angle measured will be minus in clockwise direction, right? That's why it is minus 20, you have to say. That's why if I say this is some vector a bar, I am just going out of this problem to represent the directions, or how to mention this angle theta, how you need to represent means you have to have this point in your mind. So, now a bar is make an angle minus 20 degrees with respect to negative x-axis, like this you have to say. What is the meaning of that? With respect to negative x-axis, this is above this negative, that's the meaning of negative minus sign it indicates. Okay, so with the examples while solving, right, you'll just come to know much better about those angles, however when you have to take positive or negative, all those while solving problems, right. So we can have better explanation for that. So this is about the angle, direction, magnitude and direction of what? Displacement of the particle. Now how to find out velocity now? You know displacement, how to find out average velocity for the entire journey? Average velocity, how to find out? V average will be equals to, see, V average equals to displacement divided by total time for the journey. Displacement we got already how much? 10 I cap plus 5 j cap divided by total time for the journey is how much? This is for 2 seconds and this for 3 seconds. Total time for the journey is how much? 2 plus 3, 5. 10 I cap plus 5 j cap divided by 5. Meter per second is meter per second, or V average will be equals to, V average equals to 10 by 5 is how much? 2 I cap plus j cap meter per second, like this you have to solve. This is about how to find out the average speed. Okay, so now how to find out what is the acceleration of the particle? This is very important. I just supposed to make you to learn this one first. These two are simple. Finding out velocity and displacement is easier. Now I just want you to write about acceleration. Acceleration. How to find out acceleration now? How to find out acceleration means firstly, what is the value of V1 bar here? V1 is body travel for 10 meters in 2 seconds. In which direction? X direction, means I can say first velocity is how much? 10 I cap divided by time taken is what? 2. See carefully. 10 I cap divided by 2. So how much it is? 5 I cap meter per second. This is V1. And what is V2 here? V2 bar will be equals to what? What is V2? It travelled in y direction for how much distance? 5 meters. In what time? 3 seconds. That's why it is 5 j cap divided by 3. This is 5 by 3 j cap meter per second. This is what? V2. And this is V1. What is the total acceleration of this journey means? You know acceleration is how much here? Delta V divided by total time of the journey. Time taken for the change in velocity. Change in velocity has been taken place in how much interval of time? That's what. So how much it is? Delta V means V2 minus V1. That means 5 by 3 j cap minus, this is V1 is how much? 5 I cap divided by total time of journey is how much? 3 plus 2. It is 5. Okay, or this can be written as 1 by 3 j cap minus I cap, so many meter per second square. That's how we need to write for acceleration. Magnitude of acceleration, how to find out means, this is acceleration, 1 by 3 j cap minus I cap is what? Acceleration for this given problem. Like this you have to write. How to find the magnitude means, you know magnitude how to find means mod A equals to root of 1 by 3 whole square plus their I cap component is what? Minus 1 whole square. You will get root of 1 by 9 plus 1 or 10 by 9 it is root of 10 divided by 9. Like this you have to write magnitude. Similarly direction, tan theta equals to y coordinate divided by x coordinate. Tan theta equals to y by x, you have to write ay by ax. See here, what is the horizontal component of acceleration here? In this problem, horizontal component of acceleration ax equals to what? Minus 1 meter per second square. What is the vertical component of acceleration in this problem? Ay, it is equals to 1 by 3 meter per second square. These are horizontal and vertical components of acceleration in the given problem. That's how we need to write for, how to write for acceleration. See in today's class, I have given only about what parameters we have studied there in straight line, motion is straight line. So like displacement, velocity, acceleration, there what we have studied. In plane, if it is going to be taken, how we have to write for it, that's what we have studied. With examples also I given, with some numerical also I given, so that easy for you to understand. So for I am going to wind up for today's session with this concept of acceleration. In the coming sessions, right, we are going to start with actual motion in a plane. What do you mean by that? Means we are intended to study only for the bodies moving under uniform acceleration. Any body which is moving in uniform acceleration, right, how we need to solve the problems in plane. So what exactly, what kinematic equations are going to be valid there, we have to study. And then in continuation to that topic, we are going to have projectiles and all so and so things we are going to study. So in the coming sessions, we are going to discuss all those. So I am going to stop here. We will see the remaining in the next session. Thank you.